Welcome to Mind Vault, where we explore the universe within, the human brain. Today we're tackling a question that's been lingering in the cosmic corridors of popular culture for far too long. Do we really only use 10% of our brains? This idea, my friends, is so pervasive, so often repeated that it's practically achieved urban legend status. But is it true? Does most of our gray matter just sit there idly waiting for us to unlock its hidden potential? What do you think, myth or fact? Stick around and let's unravel this mystery together. Let's journey into the realm of neuroscience, where we can actually see the brain in action. We're talking about brain imaging technologies like functional MRI or fMRI and PET scans. These tools are like cosmic telescopes, allowing us to peer into the depths of the living, thinking brain. And what they reveal is nothing short of extraordinary. Even when we're performing seemingly simple tasks like having a conversation or reading a book, fMRI and PET scans show us that vast networks across the brain light up with activity. It's like a dazzling fireworks display, with different regions firing in concert, each playing a crucial role in processing information, coordinating movements, and making sense of the world around us. The visual cortex, for example, springs to life when we see images, while the auditory cortex gets busy when we hear sounds. And when we're deep in thought, trying to solve a problem or remember something important, areas in the prefrontal cortex, our brain's executive center, become particularly active. Now let's shift gears and talk about energy consumption. Our brains, while only making up about 2% of our body weight, are voracious energy hogs, accounting for a whopping 20% of our total energy expenditure. That's like a tiny car with a gas-guzzling V8 engine. The brain needs this constant supply of energy to fuel its countless neurons, those specialized cells that transmit information throughout the nervous system. Think of neurons as the brain's communication network, constantly firing electrical and chemical signals to keep everything running smoothly. Maintaining this complex network is no small feat, and it requires a tremendous amount of energy. Now, imagine if 90% of the brain were truly unused. From an evolutionary perspective, it would be incredibly wasteful to dedicate so much energy to an organ that's only operating at 10% capacity. It's like building a massive power plant and only using a fraction of the electricity it generates. Evolution, my friends, tends to favor efficiency. If we weren't using most of our brains, natural selection would have likely favored smaller, less energy-demanding brains over time. Chapter 3. When brains go offline, the impact of damage. Let's venture into the sobering realm of brain injuries. Sadly, accidents and illnesses can sometimes damage specific areas of the brain. And what we've learned from studying these cases provides even more evidence against the 10% myth. You see, damage to even a small area of the brain can have profound and often devastating effects on a person's abilities, depending on the location and extent of the injury. A stroke, for example, can disrupt blood flow to a particular region, causing neurons in that area to die. Depending on where the stroke occurs, it can lead to a wide range of impairments, such as paralysis, speech difficulties, memory loss, or changes in personality. Traumatic brain injuries, on the other hand, can result from a blow to the head, causing widespread damage and affecting multiple brain regions. The severity of the injury depends on factors like the force of the impact and the areas of the brain affected. If 90% of our brains were truly dormant, wouldn't we expect to see far fewer consequences from brain damage? Think about it. If only 10% of the brain is responsible for our thoughts, movements, and senses, then damage to the other 90% should be relatively insignificant, right? But that's not what we observe. Instead, the evidence overwhelmingly suggests that different brain regions are specialized for specific functions, and damage to any of these areas can have a significant impact on our lives. Chapter 4. Evolution's masterpiece, the efficiency of the human brain. Let's step back for a moment and appreciate the sheer complexity and elegance of the human brain, a product of millions of years of evolution. Our brains are constantly adapting and rewiring themselves in response to our experiences, learning new things, forming memories, and refining our skills. This process, known as neuroplasticity, is a testament to the brain's incredible ability to change and optimize its function throughout our lives, and it highlights the fact that our brains are far from static, unchanging organs. They are dynamic, ever-evolving systems that shape and are shaped by our interactions with the world. Now imagine if we were only using 10% of this incredible organ. It would be like having a state-of-the-art computer with a lightning-fast processor, but only using it to browse the internet or check emails. We would be wasting its true potential. The truth is, our brains are constantly working even when we're not consciously aware of it. While you're watching this video, your brain is busy processing the information from your senses, interpreting the images and sounds, and making connections to your existing knowledge. At the same time, it's regulating your breathing, heart rate, and other bodily functions, all without you having to think about it. It's a remarkable feat of multitasking, orchestrated by billions of interconnected neurons firing in concert. Outro, the 10% myth, debunked. So, there you have it. The idea that we only use 10% of our brain is a myth. It's a scientific fallacy that's been debunked time and time again. Modern neuroscience has shown that we use virtually every part of our brain, and most of it is active throughout the day, even when we're sleeping. Think of your brain as a high-powered sports car. You don't need to be constantly driving at top speed to utilize its full potential. Sometimes you're cruising, sometimes you're accelerating, and sometimes you're idling at a stoplight. But even when you're idling, the engine is still running, ready to respond when you need it. If you enjoyed this journey into the depths of the human brain, don't forget to like, subscribe, and hit the bell icon for more fascinating insights from MindVault. Thanks for watching, and see you next time.